Today we are going to take a look at laws of exponents. We already did the first 3 laws of exponents last class, so we're going to look at the second 3 laws of exponents today. Just as a reminder, the coefficient is the number in front of the term. The base is generally the variable, and the little number that's up top is the exponent or the power. So our first law for today is power to a power. So this means that you have one exponent raised to another exponent. You are going to keep the same base and multiply the exponents together. So we have a little example over here on the right. X cubed squared. You would multiply 3 times 2 and just have x to the 6th. So let me explain why this rule is the way it is. X cubed squared means we have x cubed times x cubed. X cubed means that we have x times x times x. So x cubed times x cubed is just x times x times x times x times x times x. Well, we have 6 x's multiplied together, so we can rewrite that as x to the 6th. So the shortcut, so that you don't have to write out a whole bunch of x's or y's or whatever variable you have, is to just multiply the exponents. Let's take a look at our first example. We have 2d to the 4th, all of that to the 3rd power. So you need to be careful when you are doing power to a power, because you need to make sure that this exponent of 3 is applied to both the number and the variable. So I'm going to rewrite this as 2 cubed and then d to the 4th cubed. If you type 2 to the 3rd in your calculator, or if you figure it out by yourself, you have 2 times 2 times 2, that gives you 8. Then if we apply our power to a power rule, I'm going to multiply 4 times 3 and have d to the 12th. So 8d to the 12th is our final answer. Let's take a look at another example. I have 3a to the 6th times b over g times h to the 6th, and all of that is to the 4th power. So again, I need to make sure that I apply my 4th power to everything in the parentheses. So I need to make sure it goes to the 3, the a to the 6th, the b, the h to the 6th, and the g. So I'm going to rewrite this as 3 to the 4th times a to the 6th to the 4th. Since there is no exponent on b, I know that the invisible exponent is 1 over, same thing with the g, the invisible exponent is 1, h to the 6th to the 4th. So then I just need to see what 3 to the 4th is. If you plug that in your calculator, that gives you 81. Then we need to multiply the exponents. 6 times 4 gives us a to the 24th. We have b to the 4th, g to the 4th, h to the 24th. And I'm getting these exponents by just multiplying 6 times 4, or 1 times 4, 1 times 4, and 6 times 4. So this would be our final answer. Let's take a look at our next exponent law. Next we have negative exponents. If you have a negative exponent, then that means you are using the reciprocal. Remember when we talked about slope and perpendicular lines, if you have 2, that is the same thing as 2 over 1. The reciprocal means you flip it. You have 1 over 2. So if I have x to the negative 2 power, I can write this as x to the negative 2 over 1. I need to take the reciprocal, so 1 over x squared. And when you take the reciprocal, the exponent is no longer negative. It becomes positive. So let's look at a couple of examples. First, we have w to the negative 2. This is basically the same thing as our first example. We have a negative exponent, so we need to take the reciprocal, and our exponent becomes positive. So we just have 1 over w squared. Next, we have 9g to the negative 3 times h. You need to be very careful in this problem. The only thing with a negative exponent is the g. The 9 and the h do not have negative exponents. They both have exponents of 1. So when you have a problem like this, where some things have negative exponents, some things have positive exponents, the things with the positive exponents don't change. We still just have 9h. The g is the only thing that is going to have the reciprocal. So we're going to end up with g cubed in the denominator. Our last example for this law of exponents, we have negative 3m to the negative 2 over 5p to the negative 8. Again, you need to look carefully. The negative 3 and the 5 do not have negative exponents, so they are going to stay where they are. The m and the p are the only terms with negative exponents. Here's how I like to think about this. When you see a negative exponent, that means that you need to move that part of your expression. If you have a negative exponent in the numerator, you need to move it to the denominator. If you have a negative exponent in your denominator, you need to move it to the numerator. So I'm going to take this and move it to the denominator, and this and move it to the numerator. So I'm going to have negative 3 p to the 8th over 5m squared. And that is my answer. In general, when you are simplifying expressions, you do not want to have negative exponents in your final answer. So make sure that you always rewrite them to have positive exponents. Our last rule for today is actually the easiest. Anything except 0 to the 0 power equals 1. I'm actually going to start with example G on this. We have a whole bunch of stuff in the parentheses to the 0 power. It does not matter what all of this stuff in the parentheses is, because it is all raised to the 0 power. So this simply equals 1. If I look at example H, I have 5w times a whole bunch of stuff to the 0 power. This parenthesis part, it does not matter what is in the parenthesis, but that part is raised to the 0 power. So that part of this expression is equal to 1. The entire thing is not equal to 1 because we still have this 5w out in front. So we have 5w times 1, which is just 5w. So now let's go ahead and go back to example F. We have 6x to the 0 power. So let's ask ourselves, is the 6 raised to the 0 power? No. Only the x is raised to the 0 power. So this part of our expression is equal to 1. We still have a 6, so we just have 6 times 1, which is 6. So those are our last 3 laws of exponents. By themselves, they are not very tricky. The hard part comes when we put them together. So let's take a look at a more complicated problem that involves several laws of exponents. So I'm just going to pick some numbers and make up a problem. Okay, here there's a lot of stuff going on. We are going to use almost every law that we have learned over the last 2 classes. Now, there is not one right way to simplify this expression. You need to look at this and see what pops out to you. You could look at these x's and simplify those. Since we're dividing, we subtract the exponents like we discussed in the previous set of notes. You could look at the y's and see negative exponents and want to deal with those first. Or you might see a whole bunch of stuff to another exponent and want to deal with that first. It does not matter. Personally, I like to simplify the part inside the parenthesis first and then deal with the exponent outside the parenthesis so I don't have to deal with big numbers for the entire problem. So I'm going to start with the negative exponents. Since I have y to the negative 3 power in the numerator, I need to move that to the denominator. So I'll have y cubed. The y to the negative 4th power in the denominator needs to move up to the numerator and give me y to the 4th. Now, since I am dividing some x's and dividing some y's, I am going to deal with that. As we discussed last time, you need to ask yourself, which one has the higher exponent for the x's, the numerator or the denominator? Well, the denominator. So we know that our x's are going to be in the denominator. 7 minus 2 is 5. So I have x to the 5th in the denominator. Similarly, we need to look at the y's. Which has a bigger exponent, the numerator or denominator? The numerator. So I know my y's are going to be in the numerator. 4 minus 3 is 1. Since our exponent is 1, you don't have to write it, but you can if that helps you. Now that we've simplified the inside, I'm going to deal with this squared. As we discussed earlier in this video, make sure that you square everything inside the parenthesis. So I have 2 squared, y squared, 3 squared, and x to the 5th squared. So then I can simplify this. 2 squared is 4. I need to multiply these exponents, so I have y squared. 3 squared is 9. And then I need to multiply these exponents, so I have x to the 10th. So this is my final answer. As a reminder, next class you will review and then take a quiz. So be prepared for that.